What is up, Flutter devs? We're back again with another processing coding challenge. As you've seen in previous videos, but just in case you haven't, a coding challenge here in our port of processing to Flutter is where we take an exercise that was done by Dan over on the coding train using traditional processing, and we try to recreate something very similar using the Flutter processing port that we've been building across many videos now. And today, the coding challenge that we're going to work on is a mitosis simulation. Mitosis is the process by which one cell splits into two. In the case of what we're doing visually, that amounts to having a circle that you tap on with the mouse and it turns into two circles. And they also jitter and move a little bit before and after the mitosis process. Let me show you what we're talking about. Here's Dan's video, and I'll play just a few seconds of this so you can get an idea. But notice here that there are some translucent purple circles that we see in this sketch. And when I play it in just a moment, you'll notice that when Dan taps on one of those or clicks on one of those circles, it splits into two. Let's have a quick look. Split, split, split. So they're always in motion. They're always in motion, but then when you tap on one, it turns into two, and tap on one of those turns into two more. So that's what we're going to implement. And Dan has been nice enough to post this code online. Now, this particular sketch is in two different files, but there's still very little code involved. Let's quickly look at, kind of survey how he did what he did, and then we'll try to go create that in our own sketch in Flutter processing. Dan keeps a list of these things called cells, and that's a class that he defined. We'll take a look at that in a second, but long story short, all of those little purple circles are cells. Each one is represented by a cell object. In setup, Dan sets the canvas or the sketch to be 700 by 700 pixels, and then right out of the gate, he explicitly adds two of these cell things to the list. Nothing is drawn yet, but the list has two cells. Then we come down to draw. Dan clears the background at the beginning of every draw call, and 200 is about 80% white, so that should be a light gray. And then for every cell in the list, each cell is told to move, so each cell determines how it moves, and we just say, here, move somewhere, move somewhere, move somewhere, every single frame. And then c.show might as well be c.paint, cell.paint. In this case, Dan is delegating to the cell object the responsibility of doing whatever UI painting that the cell needs to do. In this case, it pretty much just amounts to drawing a circle with a translucent color. Now, the interaction comes with mouse pressed, and when the user taps down with the mouse, this function is run. What Dan is doing is he's looping through every cell in his list, C equals cells.getI. And if the mouse X and mouse Y, if the place the user clicked is on or inside that cell, then he runs some lines here that orchestrates the mitosis. This c.mitosis, what it does is it creates another smaller cell in a slightly different location. And you'll notice that's called twice. And then the original cell is removed. One nuanced detail to notice is that he loops from the end of the list to the beginning, because we're possibly adding more to the end of the list. So if you were to loop from the beginning of the list to the end, you would never get to the end of the list, because you'd constantly be redividing all the ones that you're adding to the end. Now, I think we'll probably tackle this in a slightly different way, because in production, in practice, when you're a bunch of professionals running around trying to get things shipped, this is the kind of looping condition that people don't expect to see, which leads to surprises, and surprises in programming are never good surprises. Now let's go look at the definition for a cell. Here's the class cell. It has a position, it has a radius, and it has a color. Now again, in production, you never use single letter variable names. In fact, even abbreviated names should be discouraged. This should be position, this should be radius, this should be color. It's okay. We have time to write the extra 4 or 5 characters. It's not an issue. There are 2 constructors for a cell. One constructor allows you to explicitly define all 3 parameters, and the other constructor has defaults. A default radius of 60, a default color, which I guess is that translucent purple, and then for the position, a random position is chosen based on the width and the height of the sketch. Now, you may notice that width and height can be accessed here without any reference to an object or a namespace or anything else. This is one of the things provided by processing when you use it as an integrated development environment. Things are hooked up for you in a way that width and height, all the stuff related to the sketch, are global. That's not going to be the case for us, so we're going to have to do something a little bit different here. This clicked method, probably not quite named what I would name it, but what this really means is the given X and Y position inside of this cell. Because if it is, then it means you clicked on the cell, otherwise you haven't. So these X and Y positions are just compared to the radius of the cell, and if the distance between where you tapped and the center of the cell is less than the radius, that means you tapped on the cell. Here's the mitosis, which creates a new cell with a small 80% the radius and returns it. Now I'm noticing that it starts at the same position. I guess we'll do that as well, but I thought the position was slightly changed as well. I guess not. The move command, which causes that jittering effect, uses p vector. We don't have p vector, but I think we can get away with just a random number. We'll look that up in the spec in a moment, but it's just a random x value, random y value, and then those are added to the current position. And finally, show down here, which essentially means paint. You get rid of the stroke, you paint the fill color, or you set the fill color, and then you draw an ellipse, which in this case is a circle at the given position with the given radius. So now that we've surveyed the code, let's go see if we can recreate that ourselves. We'll begin with the 700 by 700 size canvas. And actually, let me start this running because that's going to take a moment. But while that's starting up, we can say s dot size width 700, height 700. And I will also go start the class for a cell. We know a cell, again, wants a position, a radius, and a color. We'll say final offset position, final double radius, final color. And then we'll generate a constructor that takes those in. All right, and there's that. Okay, and we will say required. We'll come back to that in a moment. Let me save that. I just want to make sure that we do have the 700 by 700 canvas, and we do. This constructor here matches the one that Dan created where you can provide all the values, but we'd also like an easy way to just generate a cell with a default radius, a default color, and a random location. We could provide a default radius and color directly in the constructor, but we can't choose a random position in the constructor because the default values have to be constants. And by definition, a random value is not constant. Instead, what we will do is create a factory. Cell.random location. We will take in a width and a height. And I think this is just complaining because we're not returning something yet. There's probably a better name for width and height because it's not the width and height of the cell. Those are the bounds. But, oh well, we know they're the bounds. We will return a cell. Position we'll figure out in a moment. Radius had a default of 60, I believe. And then the color, let's go copy that color. The color is somewhat random, so let's see what this is showing us here. So this is red, I assume red, green, blue, alpha. So let's say color from ARGB, 100 for the alpha. The red is, we're actually going to use random multiple times in here. So let's create a random. Random next int 155 plus 100. Actually, did we create random? Doesn't matter. We need the sketch anyways. I can't remember if we created the sketch random method or not, but we don't have the sketch in this constructor, so we're not going to use it. By taking a random number between 0 and 155 and then adding it to 100, that gives us the same value down here. 0 green, and then the same thing for blue. I'm not sure why this particular combination was chosen. Like, I don't know what's wrong with green. I'm pretty sure I'm reading that method correctly, but that's good enough. And then the question that I have now is for, I guess, random width and height. That's no problem. So for position, we'll say random next int width, random next int height, and then 2 double. Or we could simply say next double times width, next double times height. That should now give us the random location that we're looking for. We can say random location and color. With those constructors, where are we going to store our cells? Well, we're going to store them up here in the state object. So we want a list of cell. And actually, let's define that like this. We'll put the type there and we'll say final. And due to the way that Flutter does hot restart and things, we're going to clear out the cells explicitly here in reassemble. Going back to Dan's code, up here after we size the canvas, we want to add 2 cells at random locations and colors. And we want the width and the height of the sketch, and we want to call that a second time. All right. And then we want to draw. So we begin by filling the background. And I think we can get that same color with 200, 200, 200. I think that'll give us the same color. And then we loop through the cells and we tell them to move and we tell them to paint, essentially. We don't have the methods yet, but one is move. And then cell, we can use the same terminology. We need to pass in the sketch, though, because our sketch behaviors are not global methods and functions and procedures. We need to provide the drawing tools to the cell itself. All right, to do on move and show to do there. The one thing I don't know for the move ability is what exactly does random 2D generate? I don't know what the min and max values are for that. So let's go look it up. Processing.org, view the reference, p vector, random 2D, returns a new 2D unit vector, meaning its length is 1 with a random direction. Okay, so both of the distance of this random vector should be 1, but it's a random direction. I'm trying to think of the most direct way to accomplish that. I think we essentially need a random angle, and then we need to grab the components of the angle. And I can't remember if we have something to help with that. I actually created an entire geometry package that would help, but we're not going to bring that in just for this little operation. Let's say random angle equals random next double times 2 times pi. That's a random angle. And now we want the constituent x and y pieces of that. So x is going to be the cosine of the random angle, and y is going to be the sine of the random angle. And I'm not really taking the time to think that through. Hopefully the positives and the negatives all work out correctly with that. And this is, we'll call this dx and dy. This is where we're moving. And then position plus equals an offset with dx and dy. Oh, and position here should not be final. And there might be something on offset that actually does some of this for us. In fact, let's see, offset. Hey, there's a direction. Let's see if that's what we want. Creates an offset from its direction and distance. The direction is in radians clockwise. Hey, it seems like what we want, so forget that stuff. We'll take this right here and we will add it right there. I think that's all we need for move. Let's go see. Yeah, I think that's it. And then we need to figure out how to paint this thing. So we'll say S, no stroke, fill with the color, and then circle. It says ellipse here, but I don't think ellipse is needed because the radius is equivalent in both dimensions. So we just need to give it the position, and then the diameter would be radius divided by 2. And check that out. Now, I think I'm going to bump that radius up quite a bit. Given this canvas size, 60 is not particularly large. So let's go with like 150. That's better. So we've got the movement and we've got the painting, but now when I tap on this thing, we want it to split into 2. Let's figure out how to make that happen. We're going to need to use the mouse. Not sure if it's clicked or pressed. Let's say clicked and see if that works. And I guess we receive the sketch. And then we're going to say, so this is where that loop is. And I mentioned the loop went from the end of the list to the beginning. What we're going to do instead is we're just going to have new cells. We're just going to create a new list. And then we're going to loop through all the cells in cells. We don't even need to keep track of the index anymore, I don't think. And then if cell, now this doesn't exist yet, but it will. We're going to say if cell contains point s dot mouse x comma s dot mouse y, then we're going to say new cells dot add cell dot mitosis, and we're going to do that twice to get 2 of them. Then at the end, we're going to say, I guess we do need an index after all because we need to remove the cell. One thing we can do also is this. And we can say cells.remove . Okay, I guess I thought there was going to be a remove all on that. let's say where old cells dot contains element. We're doing extra operations here. It would be more performant to do the removal in the loop, but I'm just letting you know this is another thing you can do. So we can remove dead cells, add new cells. So cells, see there's an add all even though there's not a remove all. So we can add all cells, all the new cells. And then we just need to provide contains point and the mitosis to return the new one. So first, Boolean contains point. And this is the one that I mentioned I would rename because clicked, the fact that it's a click really doesn't matter to the cell. The question is, does this XY position sit within this cell? And so that's all we need the method name to reflect. And then we will say final distance equals position distance with X and Y. Oh, sorry, this is the distance from the origin. I thought that there was a way to compare though. Here's what we'll do. Position minus the offset, so the difference between the two positions, dot distance. That works. And then return, if the distance between the center of the cell and the given position is less than or equal to the radius of the cell, because it's a circle, that means it contains the point, otherwise it does not contain the point. Therefore, if distance is less than or equal to radius, yes, otherwise no. Now back up here, I think we might have to cast these. These need to go, not cast, but convert to double. Then all we need is mitosis. We need to create the new cell. Come down here. We will return a new cell in mitosis. And how did Dan accomplish that? A new cell with the same position, 80% the radius, same color. We want to return a cell with the same position. The radius is radius times 0.8, and the color is the same color. All right, all the compilation issues are gone. Let's see what happens. So we're moving around, tap. Okay, we got two new ones, but we did not get rid of the old one because I did not add it. Old cells add cell. All right, now we're mitosis sizing. Let's, instead of just starting with 2, let's say for I 0, I is less than 10. Now we got a bunch of these. Uh-oh. That's interesting. So somehow I was impacting multiple cells. Something in my, I probably got some of the math wrong here in contains point. I don't immediately see what I got wrong here. Let me print the distance. Well, yeah, I mean, that distance is, oh, down here. That distance is fine. Am I treating radius as a diameter and a radius? Let's see. Radius times 2. God, I bet some of you really got annoyed by that. In which case, the default size should not be 150. That's going to be way too big. Where did I do that? In the constructor, I think. Let's take that. Let's go back down to 60 where it was actually. Yeah, plenty big. All right. Now we're dealing with some correct sizes. And maybe we can try to get a little more motion in here. So for move, instead of a unit vector, let's go with 3 times the length of a unit vector. Now we're getting a bit more jittery motion. All right, well, we're having some fun there. I think that's the exercise, right? We got everything. I think we did. So again, thanks to Dan for offering that code in the video. As always, go check out Dan's channel. Watch all of his many videos, his live streams, his coding challenges, his explorations, all of it. But we now have the mitosis effect. We could have done this exercise after the mouse interaction, but before the bitmap work. But the bitmap work was all really important, so we got that done first. And now we have a little bit of an exercise making use of the knowledge about where we're tapping. And I think we'll just keep going with the coding challenges for a little while, maybe 1 or 2 more of these, and then we'll see what makes sense for us to tackle next within the port of processing to Flutter. So stay tuned for the next video or series of videos, and I'll see you then.